Okay, very good morning, children. So, surface chemistry we are discussing. So, in this surface chemistry, what we are in the topic of adsorption, Freundlich adsorption isotherms. Yesterday we have discussed, and now we are discussing what adsorption from the solutions based on the pressure phenomenon. Yesterday we have discussed. Now we are discussing about what the same adsorption phenomenon about with the concentration. How the concentration is varying the percentage of the adsorbate based on the adsorbent mass it will be. So the extent of adsorption from the solution, it depends upon the concentration of the solute in the solution will be. You know that very well what solution can contains of what solvent and solute both it will be. So on the pressure phenomenon, how we got the equation that we know very well. Based on the concentration, we are getting a new equation that is what x by m is equals to k into c to the power 1 by n will be. So in place of pressure, we are considering as what concentration will be. That is nothing but what the x by m value is directly proportional to the concentration he is given. So C is what here? The equilibrium of the concentration of the solute in the solution. That is nothing but the mass of the solute, that is X, which is adsorbed on the adsorbent M mass, that is directly proportional to the concentration, equilibrium concentration of the solute in the solution will be. And we know that N is a constant and K is also constant value. Okay, K is a proportionality constant we are taking here. The value of K really depends upon the nature of the solid what we are taking as an adsorbent. Its particle size, temperature, and the nature of the solute and solvent. And how the equation we are getting here. Let we'll see. So if you draw a plot in between x by m values, again is the concentration of the equilibrium C value. We are going to get what the equation will be. Log x by m is equals to log k plus 1 by n log c we are going to get. But there we got as what in terms of pressure log p value we got. So these equations may be written like this, where c is the equilibrium constant that we know that, n is a constant value, and k is a proportionality constant, x is the mass of the adsorbate, and here what the solution solute adsorbate, the solute mass it will be, and this is what the solid mass, that is nothing but adsorbent mass will be. So these are the variations we are going to get what for the equations in terms of pressure, in terms of concentration, how the adsorbate mass is going to change with a concentration equilibrium and with a pressure will be. So these are the two adsorption theorems we can explain. Now we'll discuss about what application of adsorption. So in which areas this adsorption phenomenon we are using. Let we'll observe. Gas mass. Already in the previous class I told what poisonous gases get adsorbed, prevent its encounter when used by coal miners. I means what? In the coal mines like Singareni employees, like industrials, effluents where it will be released in a maximum proportions, in a higher proportion where the gases will be released, like a polymer industries and toxic gases. Well, in such type of industries, toxic gases where it will be releases, such type of situations. Most of the employees who are working at that area, they are going to earn what gas mass. So because of this varying of gas mass, what it is going to be happen? Some of the material is adsorbed on the gas mass. Already it is like our adsorbent material is already available on the gas mass. Whatever the gases are evolved there, those are the gases are completely adsorbed on the gas mass adsorbent. Because of that reason, the person who is going to wear this mask will be, that person will not breathe that toxic gases. Because of that reason, the prevention, it is a super good chemistry which is involved on the gas masks. That means what? The gases, the toxic gases adsorbed on the layer of the charcoal material, whatever the adsorbed material we are taking there. Next, if we'll observe that production of vacuum. So what is this? Traces of air are adsorbed on the charcoal and removed from devices undergoing the process of evacuation. The same phenomenon here it is working. So in the process of evacuation, production of vacuum, when we are creating that, the traces of the air or toxic gases are being absorbed on the charcoal material, which is behaving as a adsorbent and removed clearly from the devices under the process of a evacuation will be. This is one of the better use of adsorption phenomenon. And removal of moisture content. So already I told this example when we purchase the new electronic goods like AC, refrigerators, washing machines, and some electronic goods. When we purchase it, small packets are available in that. If you will observe clearly, silica gel packets will be there. So these are the silica gel packets which contains silica gel pellets, small glass type of balls are available in that packet. Those are used for the adsorption of moisture in medicines and in new plastic bottles also. It is a very good example. Everyone will know that, I think so. Why? Because if you purchase a new plastic bottle also, one packet, we are going to see that in the bottle. We will observe the plastic type of material is available in that packet. So what it will do, any moisture content it will be there, that will be absorbed on the silica gel surface. So what it will do, it is controlling the humidity there. So in order to remove the moisture also, we are using the adsorption process here. Next, removal of color. In the IIT class, I told that what the charcoal, activated charcoal, is used to used as a very good decolorizing agent because on the phenomenon of adsorption process. The juice extracted from cane is treated with the animal charcoal for the removal of the coloring agent in order to get a clear liquid solution. To remove the color from the cane sugar solution, we are using the adsorption phenomenon by using of charcoal. What will happen? The color which is present of cane sugar solution, the color can be removed and we are going to get what? A clear liquid we are getting there. Okay. As a catalyst also, as a catalyst, this adsorption phenomenon is works. Like what? Suitable materials are used as a catalyst such that reactants get adsorbed, adhered to its surface, thus enabling the reaction to proceed at a faster rate and increasing the rate of a reaction. So adsorption is also works as a better catalyst for the suitable materials, such as what will happen because of this phenomenon. Catalyst such that the reactants get adhered to its surface. Because of that reason what a faster reaction we are going to observe, increasing the rate of reaction. The reaction will be completed within a less period of time. That might show that as increasing in the rate of a reaction will be. Next, the new topic. So first, initially the topic was at adsorption, types of adsorption, mechanism of adsorption, and the graphical representation, and we got some equations also on that. Based on that, and application also we have seen. The next topic is what? Catalysis. So what is catalysis here? Catalyst is a substance which speeds up and speeds down a chemical reaction with itself being used up. That means what he wants to say is, the substance, one of the substance is going to use in a chemical reaction which does not involve in the chemical reaction, but it enhance or decrease the rate of reaction. It may increase the rate of reaction or it may decrease the rate of reaction. That it can be called alter the rate of reaction. We cannot saying that clearly, definitely it is increasing, definitely it is decreasing, may it increase, may it decrease, it will be. That type of substances can be called as a catalyst, and this phenomenon is called as what? Catalysis will be. Berzelius introduced the term catalysis in the catalyst. So he is the scientist involved in the terms. So Oswald is one of the scientists who redefined the catalyst definition as a substance which changes the reaction rate. So catalyst is means Oswald, what he said, which changes the rate of a reaction without affecting the overall energetics of the reaction, without changing of any energetics of the reaction of reactant or product. It is changing only the rate of reaction, is termed as a catalyst, and the phenomenon is known as what? Catalysis process. Okay. After that, types of catalyst, if you are going to, so catalyst definition we have seen already. After that, the catalysis means what? The process is called as catalysis. And types of catalysis. How many types of catalysis are there? Let me observe. Homogeneous catalysis, heterogeneous catalysis is second one. Third one is positive catalysis. Next, negative. After that, autocatalysis. Then induced catalysis. Acid-base catalysis also will be there. That we will discuss those catalysis process, how we define that, and what are the examples of these catalysis. We will see. See, observe children, it is one of the best example of catalysis process, how the one of the molecule is coming along with the catalyst, and it is taken another molecule from the surface, a reaction is happened, but there is no involvement of catalyst in the reaction. So if you'll observe clearly here, the red color ball, whatever it will be coming here, along with a blue color molecule, the red color ball, what it is coming here, it is a catalyst, and blue color ball is a reactant. It is adsorbed here, and from the adsorbent, one of the molecule is removed along with this. But there is no changing in the catalyst. This process is called as what a catalysis will be, without changing, without involving any chemical reaction, without involving in the chemical reaction, that it is changing what it is used, it is helpful for the completion of the reaction very fastly. Such type of substance we are calling as catalyst, and it is called as, the process is called as what a catalysis will be. Okay, this is what a better example of a catalysis process. Okay, children, after that, types of catalysis, we'll see that homogeneous catalysis. What is meant by homogeneous catalysis? A simple definition I'll give you. In a chemical reaction, any chemical reaction, if you are considering, let us observe here, sulfur dioxide is here, oxygen is here, sulfur trioxide is here. By the oxidation of sulfur dioxide, we are going to get in sulfur trioxide. We are going to use as NO is a catalyst here. In this HCl is a catalyst here. In this H2SO4 is the catalyst here. Hydrolysis of ester, HCl is used. Hydrolysis of sugar, H2SO4 is used. If you will observe in each reaction, the products are in the gaseous phase. The reactants are also in the G means what here? Gases. So it is also gas, it is also gas, it is also gas. And the catalyst also will be gas. All are in same phase. Because of that reason, it can be called as the catalyst is which in phase, the reactants and products also are in the same phase. All are in gas phase. That's why all are in homogeneous. That's why the reaction can be called as what? Homogeneous catalyst. In every reaction, this reaction is also liquid, 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 liquid. As well as in this case also, if it's in every substance which it is involved in the hydrolysis of sugar, this is also we can call it as homogeneous catalyst. We'll go with the definition once again. When the reactants and the catalysts are in the same phase, already we have seen reactants and as well as the catalysts are in the same phase, the catalysis is said to be homogeneous. The following are some of the examples of homogeneous catalysis examples will be. Okay, children. So this is about what homogeneous catalyst. So nothing, no need to worry about that. What if the reactants and catalysts both are in same phase, that can be called as a homogeneous catalyst. Okay. After that, homogeneous catalyst, once you see what is happening in the homogeneous catalyst, one of the reactant is came on the surface of the catalyst, and again one more reactant which is in the same gas phase is coming here, and it is approaching, and a rearrangement of electron takes place in third place. New product is formed and removed. See once again, I'll say this. First, one of the gas molecules are reaching the surface of the catalyst, which is also under gas condition. Both are gases only. These are gas, this is gas. Second, another gas is coming and reaching the surface of the catalyst. All are gas molecules. Rearrangement of electrons are taking place in this. A new product with yellow color molecule and green color molecule is forming and removing. Desorption is happening here. So this is what homogeneous catalyst. Everything is a gas. Green color molecules are gas, yellow color molecules are gas, as well as the surface of the catalyst also is as a gas. So first step we got what? This is what first step coming of settling down at the surface of the catalyst is an adsorption process. Another reactant approaches the catalyst, the second one. Another reactant is approaching the catalyst, the second process. Rearrangement of electron takes place, that is a reaction. In between these three will be, these two will be, and these different gas molecules, and these are different gas molecules. We can consider this at SO2 will be, this is considered as O2 will be, and forming as SO3, you can consider like that. It's a better example I'm saying that. So after the final fourth step, what is happening? A new product is formed, SO3 will be, that is a process can be called as what? Desorption. The fourth step can be called as what? A desorption will be. Okay, children. So this is about what the example and explanation of a homogeneous catalysis. What is meant by heterogeneous catalysis? So we know that all are in same phase. We are called as homogeneous catalysis. All are in different phase, and what? Nothing but reactants are in gas phase. Gas phase. Here is also gas phase. But platinum is in solid. Iron, what we are using in the Haber process in the synthesis of ammonia. Formation of oxidation of SO3, we are using asbestos as platinum we will use in the contact process. And vanadium pentoxide also we can use. That is also what these are solids, but these are gases. This is solid, iron solid, but these are reactants and products are gases. Such type of catalysis. So The definition he is given what? The catalytic process in which the reactants as well as the catalyst or in different phases. Present different phase or not, it is a gas. Arrow marks E1 one upward direction. It's an upward direction, it will be there. But this is a solid. These two are gases and this is a solid. That's why such a type of catalysis process we can call it as what? Heterogeneous catalysis. Some of the examples of heterogeneous catalysis are given. That is what? Contact process, oxidation of a sulfur trioxide, oxidation of sulfur dioxide to sulfur trioxide, and preparation of, in the Haber process we will prepare ammonia gas. That is iron is a catalyst, which is a example for heterogeneous catalysis will be. Okay, children, right? So the beautiful diagram here. Observe nitrogen molecules, green color balls are here, and sorry, these once again I'll explain you what is happening here. See here, these pink color balls are nitrogen. This is one nitrogen, this is one nitrogen, and green color balls are what? Exactly three hydrogens. 3H2 is here na? 3H2 means H2 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 like that. So this is one H2, this is another H2, this is another H2, this is N2 value. Both are reacting on the surface of the inorganic catalyst and forming as 2 NH3. See once, N and 3 hydrogens. N and 3 hydrogens are removing like that. Okay. Once again, clearly observe 3 hydrogens which are green color bonds. Nitrogen is pink color balls, and both are reacting together on the surface of the catalyst. Nitrogen and 3 hydrogens. NH3, NH3. 2 molecules are removing like that. So gas molecules absorb on the surface. So that is a solid surface. Solid surface, it will be inorganic catalyst. Upon this, nitrogen and hydrogen both are reacting together and are removed as a desorption process, removed as 2 moles of ammonia molecules. Okay, children, this is about what a heterogeneous catalysis. Ammonia molecules, how they are going to remove, once you see, right? Fine. What is meant by positive catalyst? It is accelerated by the manganese dioxide at the temperature of 270 degrees centigrade. If we have taken in this reaction, the decomposition of potassium chloride is included with we have taken as a catalyst of MnO2. What will happen here? When the rate of reaction is accelerated by the foreign substance, the foreign substance is the rate of reaction is accelerated. Accelerated means increases. Increases means what? The time taken to form the products is decreases. That is called as what? Acceleration of the rate of the reaction. It is said to be positive catalyst. And the phenomenon as positive catalysis we can call. Some of the examples are given below. So clearly we can understand that what if the rate of the reaction is increasing by addition of a foreign substance like MnO2 in this reaction and vanadium pentoxide or platinum in this reaction, such type of catalysis process we can call it as what? A positive catalysis. And what is meant by negative catalysis here? So already positive in the sense nothing but what? If the rate of the reaction is accelerated, that type of catalysis can be called as what? Positive catalysis. A negative means you only say that if the rate of the reaction is retarded, is decreased, is reduced, is stopped. Such type of words we are using here. There are certain substances which when added to the reaction mixture like alcohol here. Okay, when this type of substances are added, at that time the rate of the reaction is retarded. The retard the reaction rate instead of increasing. Instead of increasing, it is stopping. That means reduces. This type of catalysis process can be called as negative catalysis, and the catalyst which is involved in that reaction, that is can be called as what? Negative catalyst. And the phenomenon is known as what? Negative catalysis. Some of the examples here we are going to discuss. And tetraethyl lead is there. So it is a very good anti-knocking agent. Anti-knocking agent which is used in the fuels generally to compress the internal combustion of the engine generally. So it is used in the petrol fuels especially. So TEL, tetraethyl is called as anti-knocking agent, is added to the petrol to retard the ignition. To retard the ignition of petrol vapors will be. Retard the ignition of the petrol vapors on compression and internal combustion of engine, and thus minimize the knocking effect. So the knocking effect will be reduced because of the internal combustion of the engine will be. So examples, if you have seen, sodium sulfite is undergone oxidation in presence of an alcohol, the alcohol is going to be retard the rate of the reaction. Similarly, oxidation of benzaldehyde, if you have taken C1 here, because of diphenylamine, it is going to be retard the rate of reaction, and we are going to get benzoic acid. 2 moles of benzoic acid we are going to get here. Okay, after that, In this, after the negative catalysis, we will see autocatalysis is one of the types of catalysis process. What is autocatalysis? Let me will see that. So in certain reactions, so like these type of reactions, what will happen? One of the product which it is formed here, that is act as a catalyst. Such type of reactions can be called as, no additional catalyst we are taking here in this reaction. No additional catalyst is taken like alcohol, like type of catalyst we are not taking here. So even though one of the product which it is already formed in the reaction or which it is already available in this reaction, this is again act as a catalyst. Such type of catalysis process can be called as what? A autocatalyst. We'll go with the definition once. In certain reactions, one of the product act as a catalyst. I told you one of the product is act as a catalyst. That is manganese, Mn+2 here. In the initial stages, the reaction is slow. In autocatalysis process, the reaction initial stage it will be slow. Why? Because the catalyst we are not taking initially. Because of that reason, what initially it will be slow, but slowly it was what the rate of reaction is increases. But as soon as the products come into the existence, the reaction rate is increases. This type of phenomenon is known as autocatalysis. So how the reaction rate is slowly increases because of the catalyst which already included as a product in the same reaction, that is known as what autocatalysis. Some of the examples are as follows. The rate of oxidation of oxalic acid. This is oxalic acid. Rate of oxidation of oxalic acid by acidified potassium permanganate. This is the acidified potassium permanganate. Acid we have taken, potassium permanganate is there, which increases the reaction progresses. The acceleration is due to the presence of what? The Mn+2 is came here. This is of water. Presence of which ions act as a catalyst? Mn+2. It should be Mn+2 should be here. Mn+2 act as an autocatalyst will be. And this is a reaction. One more reaction he's explained here. What is that? Let me see. Observe that. When the nitric acid is poured on copper, at that time, what will happen? Nitric acid is convert as what? Nitrous acid during the reaction, which act as a autocatalyst will be. When nitric acid is poured on copper, the reaction is very slow initially, the initial stage. When nitric acid is going to react with copper, it is very slow in the beginning process. Gradually, the reaction becomes faster. Why? Because there is a chance of acting of catalyst, that is due to the formation of nitrous acid. During the reaction, the catalyst is forming. Because of that reason, what? Slowly the reaction speed will increases. So this is one of the autocatalysis example. Okay. So let me discuss about regarding what? Induced catalysis. What is induced catalysis? We have discussed what are positive, negative, and autocatalysis is we have discussed, and homogeneous, heterogeneous. What is meant by induced catalysis? Let me observe. When one of the reaction influence the rate of other reaction, which does not occur under ordinary conditions using. Induced in the sense what? Encouraging. One reaction is encourages another one. One reaction is inducing another one. So in that manner, one reaction influences, encourages, induces, induce in the sense what? Influence the meaning of that. The rate of other reaction which does not occur under ordinary conditions, that phenomenon can be called as what? Induced catalysis. That will go with some examples. Clearly, with a diagrammatic representation, I will explain once you observe here. Sodium arsenate is the solution, is not oxidized by air. See here, sodium arsenate. This is the sodium arsenate solution. When we are doing the oxidation in presence of air, no reaction. That's why we have taken a red symbol with the into mark here. There is no reaction. Why? It is not happening in a normal ordinary condition. But what he wants to see, sodium arsenate solution is not oxidized by air. If, however, air is passed through the mixture of the solution of sodium arsenate and the sodium sulfite, both of them undergo simultaneous oxidation. That will observe. Normally, sodium arsenate will not oxidize under presence of air. There is no reaction. But sodium sulfate individually, sulfite if you have taken in presence of air, it is oxidized as sodium sulfate. That's why we have taken a star symbol with a green symbol we have taken. This reaction will occur, but this reaction will not occur. So because of that reason, what we are doing, the sodium sulfate, what it will be here, the sodium arsenate, what it will be here, both we have combined together, and then we are applying the same oxidation process. At that time there is a chance of oxidation. So why it is happening? Because of this reaction, because of the influence of this sodium sulfate, because of the influence of this reaction, this is going to be oxidized here. So without the influence of sodium sulfite reaction, there is no chance of oxidation of sodium arsenate. So sodium arsenate individually, there is no oxidation. But when we had added sodium sulfite, there is a chance of oxidation. So here it will be what? Because of this reaction, the catalysis is working here. The reaction is working here. The oxidation is happening here. That's the meaning of that. So sodium arsenate solution is not oxidized by air. However, air is passed to a mixture of the solution of sodium arsenate and sodium sulfate, both of them undergoing simultaneous oxidation. The oxidation of sodium sulfite thus induces the oxidation of sodium arsenate will be because of the sodium sulfite. It is inducing the oxidation in water in sodium arsenate will be. Similarly, another example, the reduction of mercury chloride with oxalic acid is very slow. Mercury chloride with oxalic acid reaction will be very slow will be. But when potassium permanganate is added to that, is reduced readily with oxalic acid. So however, oxalic acid is added to a mixture of potassium permanganate and as well as the mercury chloride. At that time, both are reduced simultaneously. So the reduction of potassium permanganate thus induces the reduction of a mercury chloride will be. So this is the major reason. So here potassium permanganate is inducing the worked as an induced catalyst. And here what sodium sulfate is act as an induced catalyst. Okay, children, right. This is an example already we have discussed. This is what sodium sulfate is act as an induced catalyst here. While this is not occurring, because of that reason, the both mixture we have taken. So there is a chance of oxidation process. Okay. So this is acid-base catalysis. According to the Arrhenius and Oswald, those H plus or OH minus, sorry, O was not mentioned here, H plus or OH minus ions act as a catalyst will be. So acid-base catalyst in the sense, acids nothing but according to the Arrhenius, we know that what the substances which are going to be giving H plus ions in its aqueous solutions, that can be called as a acid, that we know very well. And after that, what base in the sense which are going to give what OH minus ions in its aqueous solutions, that can be called as a bases according to Arrhenius. So based on that, the acid-base catalysis also is defined at example. If we have seen hydrolysis of ester, we know that what it is a reversible process. When alcohol and acid is added at in presence of an acid at a temperature of 170 degrees centigrade, esters are formed as a byproduct of water, and it is a reversible reaction. When esters undergone hydrolysis, again we are going to get as what acetic acid and alcohol here. So this is happening in presence of what? An acid or a base here we have taken. So when acid or base act as a catalyst, that process is called as, that type of catalysis we can call as what? Acid base catalysis. Inversion of cane sugar, that is what a hydrolysis of sugar will be. So this is a hydrolysis of sugar if we have taken in presence of an acid only, it is forming a ketose, that a fructose and glucose and aldose is formed. This is also, it is happening in presence of an acid H plus. That's why it is also called as what? Inversion of cane sugar is one of the example of what a acid base catalysis will be. We will see one more reaction, conversion of acetone into diacetone alcohol. So 2 moles of acetone we have taken, CH3CO, CH3, this is an acetone will be, this is also acetone. 2 acetone molecules in presence of a base, when reacting together, we are going to get what? Diacetone alcohol we got here in presence of a base. That's why these are the examples of what? Acid-base catalysis. So once again, I'm saying the definition. The catalytic reactions which are going to be happened in presence of an acid or a base, such type of catalytic reactions we can call or acid-base catalytic reactions or acid-base catalysis will be. Okay, right. Next word, characteristics of catalysis. So what are the major characters? So types of catalysis we discussed, homogeneous, heterogeneous, acid base, like so many we have discussed in user like that. But what are the characteristics? So a catalyst remains unchanged in mass and chemical composition at the end of the reaction. Already we know that. Though, so there is no chance. So why? Because it's not involving in a chemical reaction. Because of that reason, what? There is no change in the composition. There is no changing in the mass. After completion of the reaction, also there is no changing in the mass and composition of a catalyst. And the second point, if we'll see, a small quantity of the catalyst is generally sufficient to catalyze almost unlimited reactions. So if we have considered that if the reactant's mass will be higher, we cannot be particularly say that as what the same quantity of catalyst we need to take, not like that. So even though a small quantity of catalyst also will lead a high quantity of reactants will be. So that reaction does not say that what exact the same quantity of catalyst is required, a larger quantity of catalyst is required, not like that. Even though a small quantity of the catalyst is in generally sufficient to catalyze as almost unlimited reaction, so many reactions. Why? Because there is no changing in the mass, no changing in the composition. So for unlimited reactions, the same catalyst we can use it. So there is no loss in the catalyst. Because of that reason, what we can use the same catalyst for so many reactions. And the catalyst cannot initiate the reaction. The function of the catalyst to alter the speed of the reaction rather than to start it. After starting the reaction, it can enhance the speed. It can decrease the speed, but it cannot start the reaction. That is the meaning of the catalyst. So don't think children like that as what a catalyst only will start the reaction. No catalyst will start the reaction. Catalyst, after starting of the reaction, will speed up the rate of the reaction, will decrease the rate of reaction, will alter the rate of the reaction, either increase or decrease. It will change, but it never start the reaction. That is one of the property of the catalyst will be. So fourth point, if we'll observe here, the catalyst is generally specific in nature. Definitely, for a specific chemical reaction, we need to use a specific catalyst. Yes or no? Fine. Now, the catalyst is generally specific in nature. A substance, if we have seen, which act as a catalyst for a particular reason, a substance which acts as a catalyst for a particular reaction fails to catalyze as other reaction. Different catalysts for the same reactant may for different products. So it is also one of the important point we need to observe here. What is that? For every reaction, it's not clear that for every reaction, for any reaction, we should use same catalyst. It's not like that. For different reactions, different catalyst will be there. If for the same reaction, if we are using different catalyst also, we are going to get different products at the same time. It means what? For the different reactions, different catalyst may use. For the same reaction, if the different catalyst is used, we are getting different products also. That means for all the reactions, no same catalyst is used. For the same reaction, different products if we get means different catalyst we should use. Okay. After that, one more property we'll see. The catalyst cannot change the position of the equilibrium. It does not alter the position of the equilibrium. The catalyst catalyzes both forward and backward reactions to the same extent in a reversible reaction and thus have no effect on the equilibrium constant. Clearly, you should remember this. Catalyst never change the equilibrium constant. It can speed up the process of water, especially speed up the process of completion of the reaction, rate of the reaction. Catalytic promoters, the substances which themselves are not catalysts, but when mixed in small quantities with the catalyst, increase their efficiency, are called promoters or activators. So the efficiency, when it is increases, small quantities with catalyst increase their efficiency, those are called what? Promoters and activators. This is important for what? A 2 marks question in your IP. For example, in Haber's process, if we will see, for the synthesis of ammonia, traces of molybdenum increases the activity of finely divided of iron, which acts as a catalyst. So promoters, what they will do, increases the efficiency of the catalyst. Okay, so molybdenum, it will be there. Molybdenum traces, what they will do, increases the activity of the catalyst will be. So catalytic poisons. Poisons are nothing but the substances which are increasing the efficiency of the catalyst. Those are called as promoters, or we can call them activators. Which activate the activity of the catalyst will be. But whereas if you have taken the poisons, what is meant by poison here? Which decreases the activity of the catalyst, which going to be decrease the activity of the catalyst. By means of that, what catalytic poisons substances which destroy the activity of the catalyst by their presence are known as catalytic poisons. The activity of iron catalyst is destroyed by the presence of a CO in the synthesis of ammonia by Haber's process. By means what? If catalytic speed increases, whatever the substances we are adding, those are called promoters or activators. If the catalytic activity is reduced, those are called or what? Poisons will be. Okay, children. Next, if we'll see that theories of catalysis. What are the theories of catalysis? So catalysis is completed. After that, how types of catalysis are finished. After that, what characteristics of the catalysis? Catalyst, what it will alter? Catalytic speed, how it will increase? Catalytic speed, how it will decrease? That we have discussed. There are two theories of catalysis, which described as follows. One of the theory is what? Intermediate compound theory. By means what? What are these theories means? When a catalyst is involved in a chemical reaction, how the catalyst is participating, what type of reactions are happening inside the reaction, how catalyst is participating in the reaction, how it is helping for the formation of products. That we'll discuss in this theory. This theory was proposed Clement and Desormus in the year of 1806. According to the theory, the desired reaction is brought about a path involving the formation of an unstable intermediate compound followed by its decomposition into the desired end products with the regeneration of the catalyst. So how the reaction is going to be happen, he is explained here. What is happening here? The desired reaction is brought about by a path involving the formation of an unstable intermediate compound. So by using this catalyst, what is happening? An unstable intermediate is formed, compound is formed, followed by its decomposition. Again, decomposition is happening, and the desired products we are getting here after the regeneration of the catalyst is also happening. That the intermediate compound may be formed in either two ways. When the intermediate compound is reactive and reacts with other reactants. So two conditions are there. So we'll see that this is what the catalytic surface with free valence is. One reaction is happening here. That reaction we are observing this, the catalytic reaction. So this is one of the catalytic surface which is having a free valencies here. These are the free valencies or pores having a catalytic surface with the free valencies, and it is reacting with the molecule A and as well as molecule B will be. So there is a reaction in between this. Adsorption of reacting molecule in the second step. What it is happening here? So A is reacting with the free valencies and B is also reacting with the free valencies. And in the third step, what it is going to be happen? Free valencies are there, along with that A is adsorbed, one of the reactant molecule, one of the B reactant molecule B is adsorbed here. After that, in the third step, there is a intermediate, unstable intermediate is formed. Already we have discussed in the previous slide. An unstable intermediate with the catalyst, it is formed. This is a catalyst free valencies which is having, and an unstable intermediate is formed. There is a bond in between A and B. In the last step, what we are going to get? The desorption of product molecule. Desorption in the sense what? The bond which it is present in the catalyst surface, and this catalyst surface, it will be B and A, that can be broken, and desorption is happened. The catalyst is regenerated. The same catalyst is regenerated here. Again, the catalyst came without any changing of its valencies, without changing of any structure and mass and composition. We got a same catalyst, regeneration of catalyst. There is A and B are the reactant molecules which are individually present here. But after completion of the total reaction, there is a new product is formed, that is A. The bond is existing in between A and B will be. So this type of catalysis process is going on in this reaction. This is what one of the theory of catalysis. This is what? By the formation of unstable intermediate compound, then we are going to get what? A new product here. By means what? By the formation of unstable intermediate, we are getting new products because of the catalyst surface. Okay, this is one of the theory will be. Then after that, adsorption, the second theory. What is the adsorption theory here? Theory is applicable to reactions between the gases in presence of a solid catalyst. So these are the gases in presence of a solid catalyst forming a new gases. That is what? 2 moles of ammonia. Nitrogen is a gas, hydrogen is a gas, forming an ammonia gas in presence of a solid catalyst. the contact process, if we have observed here, because of the adsorption phenomenon only, direct adsorption phenomenon, we are getting a new products here. Contact process, if we will see the oxidation of SO2, it was not clear here, SO2 to convert as SO3 with atmospheric oxygen. SO2 plus O2 gives what? SO3. In presence of a platinum catalyst or vanadium pentoxide is used as a catalyst in the contact process. A contact process which it is used for the preparation of a sulfuric acid. Okay, in that adsorption phenomenon is working. In the Haber process, iron is used as a catalyst, and in this of ammonia also, preparation of ammonia also, iron is used as a catalyst. So this is also what one of the adsorption phenomenon which works adsorption theory will be. So next topics, very important topics which we are going to expect in the next IP exams. And every year, these questions we may expect. What are those? Activity and selectivity will be. What is activity and what is selectivity? Activity is the ability of a catalyst to accelerate the chemical reaction. So what he's saying, so to accelerate the activity of the catalyst, to accelerate the activity of the chemical reaction, the degree of acceleration can be as high as 10 to the power of 10 times in certain reactions. In some reactions, what he is saying, the chemical reaction, what will happen? It will accelerate. The rate of reaction can be accelerated 10 to the power of 10 times because of the ability of the catalyst. That it can be called as what? Activity will be. For example, if we have seen reaction between hydrogen gas and oxygen gas, to form as H2O in presence of a platinum as a catalyst, it takes place with explosive violence. So this is what activity we can call. It is the ability or a catalyst. Activity is the ability or catalyst to accelerate the chemical reaction. So the ability of accelerating a rate of a chemical reaction is called as what? Activity will be. This is one of the example. In absence of catalyst, H2 and O2 can be stored indefinitely without any reaction will be. So this is means what? Activity will be. What is meant by selectivity? So these are the two important questions for IPE program, children. So the another question will be what is selectivity? It is the ability of catalyst to direct reaction to yield in particular products will be. So which catalyst we need to choose? Which catalyst we need to select? So that is the ability of catalyst to direct the reaction to yield particular products. To get a particular product, a particular catalyst should be chosen. To get a particular product, definitely this catalyst only required. If we are using different catalyst, what? Different products we are getting. That means what? A specific, a selective catalyst only used for the selective product. The meaning of that, if we have used platinum here, we are going to get this compound. Otherwise, another catalyst if we are using, other products we are going to. So selective catalyst is used means the required products only we are getting here. So N-heptane, which is it is undergone with the catalytic reaction of platinum, we are going to get as what? Toluene. And as well as if we have taken a propene molecule in presence of the catalyst, we are getting what? Acrolein will be. If the catalysts are changed, selective catalysts are these only. If the catalysts are changed, because of that reason, what? The yield, what we are going to get, different products we are getting. So this is about what activity and selectivity will be. So this is about activity and selectivity in this. After the catalysis process, what is catalysis? Applications of the catalytic process, characteristics of the catalysis, and theories, adsorption theory, and as well as intermediate compound theory also finished. And after that, activity and selectivity is completed. After that, what is the shape selective catalysis? Shape selective catalysis. What is meant by shape selective catalysis? If we will see, catalytic reaction that depends on the molecules of the product. So it is a very important topic here. What is selective catalysis? It is nothing but majorly in this shape selective catalysis, zeolites will be involved. So let me go with the definition. Catalytic reaction that depends on the molecules of the product and on the size of the reactant and the catalyst pore structure. So my means easily we can understand this. Why? Because whatever the pore size of the catalyst will be present, based on the size, these are the reactant molecules will penetrate into that. At that time, a new compound is going to be formed as a product. So that's what, based on the shape the shape of the catalyst. These are the reactants molecules are penetrated into that. So selective shape, based on the selective shape only the catalysis is going to be occurred. Example, if we will see the